In this video, we're going to continue to look at rational functions and identify holes that occur on the graph. So a hole occurs anytime there is a factor in the numerator that is equal to a factor in the denominator. So we can see in the first example that's already factored for us. Remember, you always want to factor first. But here we already have a rational function that is factored. We could see that there is a factor that is the same in the numerator and the denominator. So there is a hole when x plus 1 is equal to 0. So if we solve this, there is a hole when x is equal to -1. Now, we want to find, once we find or identify the x-coordinate of the hole, now we want to find the y-coordinate of the hole. And in order to do so, we are going to take that x value and we are going to substitute it into the function for the remaining factor or factors. So think of this hole right here, think of those as just like canceling out because they're equal. So we're going to take -1 and we're going to substitute it into the function in the remaining factor. And now I'm just going to do the math here. So this just ends up being -2. So that is our y-coordinate of the hole. So our hole is at -1, -2. Now, one thing I just want to bring up while we're here is when we talked about vertical asymptotes, we would factor the denominator and we would find when the denominator equals 0. And we would do something like this. And we'd solve this and say, hey, this looks like there's a vertical asymptote at x equals -1. Well, that's not the case in this situation because there's not vertical asymptote there. There is a hole there. And we would see that if we were to graph this. So let's take a look at that. So I don't have this ready to go, but let's do this right now. X minus 1 times x plus 1, oops, excuse me, divided by x plus 1. Okay, and you can see there is certainly not a vertical asymptote when x is -1. Okay, this is just a line that passes right through there. Now, this is a line that has a hole when x is -1. Now, the only downside to Desmos is that Desmos does not show the hole on the graph. But if you move this point, okay, notice right there it says -1, it's undefined. So it's indicating that there is a hole there, but you have to actually physically put your finger on the line and find it. Okay? So, little downside to Desmos, but I don't want to badmouth Desmos because I love it. So let's look at the next one. So the next one is not factored, so want to make sure that we factor that before we start. Okay, so now we're looking for a hole. Now notice, we have the same factor in the numerator as we do in the denominator. So we're going to have a hole at x minus 2 is equal to 0. So if we solve this, we have a hole when x is 2. And now we're going to substitute that into the remaining function. Oops, this is g of 2. So now I'm going to substitute it in to x plus 1, so that becomes 2 plus 1 over 2 plus 2. Just going to do the math there, we get 3/4. So the hole is at 2 3/4. Okay, now one more example. So we have 2x divided by 3x squared plus 1. First step is always to factor. We can't factor this. Now we're looking for a whole. If we do not have the same factor in the numerator as the denominator, then there is no whole. So in this case, there is no whole. Okay, so we've looked at an example where we have had a whole with a remaining factor. We've looked at an example where we've had a whole with a remaining factor in the numerator and the denominator. And we've looked at an example where we do not have a whole. If you want to see or watch or learn anything more about graphing rational functions, you can check out the next video.